categories divided. 2 categories. What are those? Collections, framework collections. Next, legacy collections. Okay. Collections, framework collections means JDK 1.2 and above versions. Legacy collection means 1.0 and 1.1. Okay. Collections, framework collection, how many subcategories divided? 3 subcategories. What are those? Core collection interfaces, general purpose implementations, more utility collections. Okay. Core collection interface, how many are there? 10. General purpose implementations, how many? 10. More utility collections? 7. Out of 7, how many completed? 6. Last one, comparator interface. Comparator interface. It is used to compare elements of a collection. It is used to compare elements of a collection. It is used to compare elements of a collection. See, comparator interface used to compare elements of a collection. Okay. Now, I'll show you. Java P java.util.comparator. Method. Nodal. Java.util.comparator. No. So comparator interface contains compare method. With this method will compare these 2 elements. It returns one integer. If this is greater than, that is, it is actually abstract method. This method we ought write. This method we ought write. Because yesterday I was shown, that is, I'll show you once again. Is it over? See. For yesterday concept purpose only, this interface required. Yesterday I given this one. You observe these employee number, name, salary. These are which type of variables? How to initialize? Constructor. Parametered constructor. This dot employee number equal to employee number. This dot name equal to name. This dot salary equal to salary. Okay. After that, yesterday I given toString also. Now public string toString. Return employee number plus /t plus name plus /t plus salary. Okay. You observe employee class, open brace, 3 instance variables I initialized here. Okay. It is toString method. This is one class. Here, employee E1 equal to new employee. Suppose employee number 1 or 2. Employee name support CCC. Salary 6,000. Okay. Employee E2 equal to new employee. Employee number 101. Okay. Salary name P. Salary 7,000. Employee number E3. New employee 103. AAA 8,000. Like this I given. Now, you observe it is the one employee class which contain 3 instance variables. These all variables initialized here. Okay. Here toString method returns these all elements concatenated as a one string return. Employee objects created. Array list. Which type? Employee type. New array list. AL.add E1. AL.add E2. AL.add E3. System.out.println AL. Input java.util.start. File save. Compilation. Execution. You are getting data now? Now, what I'll do is instead of this one space I'll write. One space. Okay. Now, here, when toString method implicitly called, whenever object or object reference is passed as a parameter to a method. Here, what is E1? What is add? E1 passed as a parameter to add method. Here implicitly which method called? Here which class toString called? This is called. Okay. That means employee number, name, salary stored here. Here which toString method called? Abstract collection. In the array list class not there. That super class also not there. That super class. Okay. In a collections, abstract collection called. Now, like that, here all printed. This is clear. Now, what I'll do, collections dot sort. Sort method yesterday given. What is the parameter? What is the parameter? List. Can I pass array list? Yes. Now system.out.println AL. Okay. Now, if I compile error. Okay. Now, here we are getting error. Why we are getting error is in a one object, 3 fields are there. Then how it will understand what you are going to sort, whether employee number or name or salary. It doesn't know. Then this sort method will show error. Incompatibility problem comes, data type compatibility. What it has to compare, it doesn't know. That's what some comparison logic you need to provide in the sort method. For every sorting method, comparison logic required or not required? So how will sort? Comparison required? Each one element you have to compare with other elements. Now, comparison logic we have to provide. Sorting logic no need to write. Only comparing the logic. Okay? Why that comparison logic is, it doesn't know what you are comparing. Suppose example, I want to display employees data. I want to display employee numbers in ascending order. Then which one employee, first employee? 101. Then E2. Next 102. That is E1. Next 103. That means E2, E1, E3. Suppose I want to display names in alphabetical order. E3, E2, E1. Suppose I want salary in ascending order. That's what I given different. Okay. That's what only given. Now, if you compare, if you want employee number based E2, E1, E3. Name based E3, E2, E1. Salary based E1, E2, E3. That is. Okay. Like that we have to display. Now, in these 3, you select one only. Either number you want to compare, or name you want to compare, or salary you want to compare. But number sorted, name sorted, salary sorted means many problems will occur. Okay. This employee number, other person name. Other person name, the another employee number. Salary is also changed. Totally changed. Okay. Like that we should not compare. While sorting, what will happen? Wherever 1 or 2 is there only this should be there. That position should not change. Wherever 1 or 1 is there only this should be there. Okay. Like that required. Now here, wherever 1 or 3 is there only this is required. Okay. How to sort? Here, collections class, one method is there. Java.util.collections. Here, sort method. Here, sort method. This is one sort method. It is list. This sort method you observe. List is there. Comparator is there. Now, comparator we have to pass as a second parameter. Okay. Comparator. Is it class or interface? Can you create object? No. Then comparator subclass object can I pass? But subclass you create. That is we have to write the logic. That's what that interface we have to implement. What I'll do, see here. One class name, something A, implements comparator. Okay, comparator, it is employee type comparator. Okay. Now, class A implements comparator. Can I pass A object? Can I pass new A? We can pass now? Now, what I want to compare is employee numbers I want to compare. Now, your class name, something I'll write instead of A, employee number comparator. Okay. In the place of A, I written employee number comparator. Here, Can I write new employee number comparator? Okay. No. Okay. Employee number comparator implements comparator. So here actually what it takes parameter? What it takes? Actual parameter. Comparator. What I passed? It is subclass of comparator. It is called upcasting. Okay. Now, but implements comparator I written. Then compulsory you have to override no method. There are remaining methods are non-abstract. That is only abstract. That method I given just now. What is the method name? This is public is there. What we have to write? Public. Return type. Method name. T means employee. T means employee because I written here. Okay. What we have to write? Public int compare emp e1 e now here employee e1 employee e2 not this one. These are local variables here. These are local variables here. Different. Okay. Now here comparison logic what we have tried is if E1 dot employee number greater than E1 E2 dot employee number return else if E1 dot employee number less than E2 dot employee number return -1 else return 0. That's it. This logic we have to write. Now it will be started. See, file, save. Previously the output. See, sorted. What is sorted? You observe. Employee number started. Starting that logic just I applied. Then actually what will be happen in a sorting generally 101, 105, 103, 102, 104 like this we have elements. Okay. Now first these two compared. These two compared, it is less than or greater than 101 greater than or 101 less than. If it is greater than interchanged, not greater than as it is. Then what will happen? 101, 105 as it is. 103, 102, 104 like this. Okay. Now what will happen? These two compared. 105 greater than 102, 103. Then interchanged. 103, 105. Okay. Next, these two compared. 101, 103, 102, 105. Next, 104. Now, these two compared. 101, 103, 102, 104, 105. Now, this is in right position. Now, again, same process. These two. Again, these two. Again, these two. Then this will come. Right position. Later, this will come. Here, this will come. That is bubble sort. in a data success is bubble sort, quick sort, ANSI sort, so many topological 10 plus sortings. Like that, comparison logic only I provided. Sorting logic already present because sorting library method I'm calling. Sort library method, new EMP comparator. This will help you for interchanging. Interchanging logic already written. What it will do? If it is +1 comes interchanged. -1 comes not changed. 0 comes not changed. That logic already written. What we are supplying +1 or -1 only we are supplying. That is this one. Is it clear? No. Now, names I want to sort. What we have tried? Collections dot sort AL. Here, one more object, one more class. One more class. Think yourself what we have tried. Class, one class name. Name comparator. Okay, this is whatever you want, you can write. Comparator. Implements comparator. EMP. Next. Public int compare E1 EMP E2. Next. E1 dot name greater than E2 dot name, return 1. Else if E2 dot E1 dot name less than E2 dot name, return -1. Else return 0. But this here employee number, which type? Name which type? In the string class only compare method is there. This logic also no need to write. This logic no need to write. What you can do, instead of writing like this, in a string class, predefined method is there. Not Boolean, int. Int x equal to E1 dot m dot name dot compare to E2 dot name. This method in which class? String class. E1 dot name is which dot name is? This string compared. There +1 or -1 automatically comes. Already written. Then return x. But instead of writing this one, directly return E1 dot name dot compare E2 dot name over. Compare to. In the string class, compare to method is there. Java p java dot lang dot string. See this method. Okay, compare to method is there. Now comparison logic also no need to write. If you string. Okay. This method I called return E1 dot name dot compare to E2 dot name. Then here what we have to pass? What you have to write? New name comparator. We can print system.out.println AL. File, save, compilation, execution. Here, first my order. It is my order. Okay. It is 101, 102, 103. Number, year, name, triple A, triple B, triple C. Okay. If you want salary comparator, one more you can write. One more you can write. That's
Recording in progress.
So here subclass of comparator, subclass of comparator, subclass object, subclass object I passed as a parameter. So sorting logic inbuilt. Here I passed employee number comparator. Whatever we passed logic, whatever we supplied, based on that it is sorted. Here name. Okay. We written only comparison logic. We didn't write sorting logic. That is also why do we record is it doesn't know what you are going to sort. It cannot understand. That is the reason we have tried. Okay. So in an object, so many variables will be there. But which variable you are going to sort, how it will understand? That is the reason we have to pass. So if it is integer here, then that is not required. Only float, not required. String, not required. But employee, in that three variables are there. Got it? That purpose comparator. But in interview, they'll ask one question. What's the difference between comparator and comparable? One more interface is there. Comparable. This is they'll ask what's the difference. I'll explain. Here, comparable also is there. You observe comparable. Here a comparative method. Now, note differences between comparator and comparable. Differences between comparator and comparable. Differences between comparator and comparable. Write it. Java.util.comparator. Here, java.lang.comparable. Java.util.comparator. This is generic class or non-generic? Generic. It is also generic. Not done. It contains the following method to compare. It contains the following method to compare elements of a collection. It contains the following method to compare elements of a collection. Here, it contains the following method to compare elements of a collection. So your method name compare. Your method name compare to. And this method takes two parameters. This method take one parameter. But if you want to compare two parameters, require, but how it will compare? Okay. First of all, you observe for calling this method also one object required. For calling this method also one object required. You'll pass two parameters. These two parameters compared here. For calling this method also an object required. That object, this object compared. But for calling purpose we use, that is ignored. That is ignored here. Here that is considered. Now, this method if you want to call, one object required. That object calling purpose only used. Comparison purpose not used. But here calling purpose also that object, comparison purpose also that object only. Here two parameters, these two compared. For calling this purpose, one more object required. That is not considered to compare, only calling purpose. But here, calling purpose, whatever object you are using, that object is parameter compared. Okay, I'll explain with example. Second. Here, two parameters are compared. Here, current object and parameter compared. Here, two parameters are compared. Here, current object and parameter compared. Here, comparison logic comparison logic can be in any in your comparison logic can be in any other
Recording in progress.
here example. Here example. Is it over? So here these two compared. Here for calling this method one object required, that object, this object compared. That's the difference. Here example I'll give. Over. See. Suppose class employee, integer employee number, string, name, float, salary. Okay, something other code. No. Another class, demo comparator, implements comparator. In public integer compare employee E1, employee E2. Okay, if E1 dot employee number greater than E1 dot E2 dot employee number, return 1. Else if E1 dot employee number less than E2 dot employee number, return -1. Else return 0. Now here class demo public static void main string args. Okay, here actually this is not required. Now you observe, because starting logic we are not reading. Here for calling this method, which object required? For calling this method, which object required? Confidently you are not giving us. What we required? Demo comparator object required. With the demo comparator object, we are calling this method. But what we are comparing? Employee objects we are comparing. Employee objects we are comparing. That logic we written in demo comparator class. You can write, because this one we are comparing. You can write here 2 parameters are there, 2 you can pass what you are comparing. This is comparator concept, but comparable concept different. Now what's right is one example. Write this one. Comparator side example. Here, which class objects are compared? Employee class. But in which class compared? Demo comparator. Okay. Over. Not done. In the above example, employee objects are compared in demo comparator class. In the above example, employee objects are compared in demo comparator class.
Recording in progress.
In the above example, employee objects are compared in demo comparator class. Okay. Is it over? Now, I'll ask one question, give me answer. First, is it over? See. Suppose, if you want to call this method, which class object you have to create? Demo comparator object you have to create. With that object, compare method you have to call. Okay. But which class objects you have to pass? Employee class objects you have to pass. Two employee objects you have to pass. Suppose I'll write here. Now you observe. It is now this method here implements comparator EMP. Class employee implements comparator EMP. Now this method overridden in employee class. For calling this method, which class object required? Employee class. It takes how many objects? These two objects. Here one more object required, but that object not considered. But you can write here also. Logic here also you can write. Now, comparison logic. Yeah. Now in this example, which class objects compared? That logic in which class present? Same class. You can write, but that is not possible. That is possible like this only. I'll explain here. What you do is left side only, or write this one, or left side only, comparator side only. One more. Comparator side only, left side. Because comparator both possible. That's what. Here, which class objects compared? Employee class. In which class? Same class. Write this one. In the above example, employee objects are compared in employee class only. In the above example, employee objects are compared in employee class only. In the above example, employee objects are compared in employee class only. Is it over? See. Suppose implements comparable. Okay. Implements comparable. What is the method name? Compare to. How many objects you have to pass? One only can pass. Now, for calling this method, which object required? Employee. Parameter. That one, this one compared. Outright logic. This dot employee number greater than e dot employee number. Is it required to write this keyword? Is it required to write? No. Now, here, this dot, when it is required, local variable name same is there, not there. Only employee number dot e dot employee number. Okay. Here, employee number dot e2 dot employee number. That nothing but e. Over. This is comparable. Now, for calling this method, we use one object. That is this. This implicitly present and greater than this object. Then compared. Like this we'll write. Now, here, which class objects compared? In which class written? Now, this code, can you write in the demo comparator? No. Because demo comparator, if you write demo comparator object and employee object, can you compare? No. This is logic should present in the same class. But that logic anywhere. Now write this one example, right side. Example, right side. Note, in the above example, employee objects are compared in employee class only. In the above example, employee objects are compared in employee class only. Okay. Here, for calling this method, which class object required? Employee. Here, one more employee. That employee, this employee compared. Suppose this logic, if I write in demo comparator, for calling this method, which object required? Demo comparator. Demo comparator employee. Can you compare? No. That is a problem. So, what is the main difference between comparator and comparable? Here, logic should present in the same class. There, same class also, any other class also. But one more problem is there. Here, comparable, compulsory, same class. Okay, same class, employee class. What we are comparing? Employee numbers. Can you write again one more for comparing name? Not possible. Not possible, no? Overriding in the same class, not possible. But there, n number of you can write. Employee number purpose 1, employee name purpose 1, salary purpose 1, n number of you can write. But can you write here? One only. That is the problem. Okay? That is only concept. So that means here comparison logic must present in the same class. That is only problem. Now, that's what utility collections only popular. Java.util. Up to here, collections framework collections, 27 collections completed. Okay. Legacy collections are there. That is just a theory because no one will use. Difference between legacy and old collection. That is maybe Monday class. Monday it will finish. Tuesday, Monday collections, Tuesday onwards, multi-threading. Okay. Just only 2 topics left. Multi-threading and synchronization. After that, new features. Okay. Legacy collections. These all 2 weeks required. 2 weeks. Okay. We'll see continuation on Monday.